Good morning. My name is Sonia Pujol. I work at Brigham and Women's Hospital and Harvard Medical School in Boston. And I'm very pleased today to give you this talk together with Colton Barr on open source neuronavigation for low resources healthcare settings. I would like to thank Eva and Miguel for inviting us to take part in this workshop. I wish I could have been there on site in London today, but the Hamlin Symposium this year was during the same week as our 3D Slicer project week that we are running this week at MIT. So I would like to start by giving some numbers on the current state of neurosurgery in Africa. So starting with West Africa, in Mauritania, a country with a population of 4.7 million people, there are only 15 neurosurgeons. In North Africa, in Tunisia, a country with a population of 12 million people, there are only 73 neurosurgeons for the entire population. In East Africa, in Ethiopia, which is the second most populated country in Africa with 123 million people, there are only 66 neurosurgeons. So if we use the ratio of Ethiopia and we apply it to the population of the UK, it is as if in the UK, there were 36 neurosurgeons for the entire population. So these three countries, Mauritania, Tunisia, and Ethiopia, represent a total population of almost 140 million people. And for this number of people, there is one neuronavigation system only available. So NeuNav aims to bridge this gap. NeuNav aims to provide accessible neuronavigation technology in low and middle income countries. NeuNav was initiated and is led by Professor Alexandra Golby, who is a neurosurgeon at Brigham and Women's Hospital and professor of neurosurgery and radiology at Harvard Medical School. So neuronavigation can make inoperable lesions operable. It can be used to avoid surgical errors such as wrong side or wrong site surgery. It can help optimize craniotomy placement and aid ventricular cannulation. And in general, neuronavigation in low and middle income countries provides a helping hand to surgeons practicing in isolated settings. So now I'm going to give you a quick description of the different components of NeuNav. And Colton, following this talk, will give you a live demo of the system. So NeuNav is built upon open source software that includes the 3D Slicer open source platform for clinical research and the Plus open source library. So here you see the user interface of NeuNav in the planning stage, when the clinical end user is defining the trajectory for the craniotomy. NeuNav uses low-cost hardware that includes an optical tracker, a pointer, and a reference array. And this is a NeuNav workflow. So after loading the patient data set into the system, we start by segmenting the skin. Then we segment the tumor. Then we define the trajectory for the craniotomy. And then we define the landmarks that will be used for the registration step. So the landmarks are defined on the surface, on the 3D model of the skin of the patient. So the registration step starts by calibrating the pointer, and then we do an initialization using a classical pair point matching algorithm. And we refine this initial step using dense registration. Once the registration step is completed, the surgeon can start real-time neuronavigation. So here you see the clinical end user is moving the tooltip of a surgical instrument on the surface of the phantom head skull. And the system is displaying in real time the position of the tooltip of the instrument in the 3D surface model of the head of the patient, as well as in the reformatted preoperative CT scan data. So building the open source system and assembling the whole NUNAV system was a big step in the creation of this project about neuronavigation in low and middle income country. The next step is making sure that the end users for whom this system was developed can use the system safely. So the NUNAV project provides training for sustainable neurosurgical capacity building in low and middle income countries. We have collaborators and potential pilot sites both inside Africa and outside Africa. So our pilot sites in Africa include Morocco, Senegal, and Rwanda. We have installed a NUNAV system in each of these 3 countries. And we are currently building a collaboration with Ethiopia and Benin to install this system in these 2 countries as well. We also have installed NUNAV in countries outside of Africa that include the Canary Islands, Italy, and Canada. So the training of NUNAV consists in 2 parts: training on the fundamentals of neuronavigation and providing hands-on experience on the use of the system. So the key concept that we teach in NUNAV courses include the DICOM file format, the basic of image segmentation, the basic of image registration, the principles of optical tracking, and the principles of real-time navigation. And one important concept also that we try to convey is that there are technical limitations in neuronavigation. And we try to teach the clinical end users to be aware that the system cannot be relied 100%, that the system can have errors or bugs, and that it's really important to be aware of the technical limitation of neuronavigation in general. So these are example slides of the NUNAV training compendium. And so these slides provide step-by-step guidance to the clinical users on how to set up the system and how to use NUNAV to perform neuronavigation. We try to assemble a comprehensive set of training materials that include not only these step-by-step tutorials, but also a YouTube NUNAV channel that contain small videos to demonstrate how to set up the system, as well as a comprehensive user manual that we try to keep up to date with the latest version of the software. A very important part of training is the notion that it's not just the surgeon that needs to be trained, it's a whole neurosurgical team. This includes the neurological nurses, the surgical technologists, the neurosurgical residents and fellows, the biomedical engineers, as well as the researchers. For us, it's really essential that each member of the neurosurgical team has a clear understanding of the key concept underlying neuronavigation and of the practical aspect of setting up the system and using NUNAV. So NUNAV is an ongoing process, and there are many challenges that we are working on. So the first challenge is ensuring that loading the patient data set into NUNAV is as simple and as smooth as possible for the clinical end users. It might sound a very straightforward step, but it's not, and we are putting a lot of effort in making the experience as smooth and as easy as possible for the clinicians. A second set of challenges that we are working on is the usability testing in a diverse set of neurosurgical teams that can have different needs, different preferences, and different expectations. A third challenge is that when we install NUNAV in a clinical site, we know this is going to disrupt the clinical workflow. So we work with a local clinical team on the development of new clinical workflows that integrate NUNAV. And then finally, a very important aspect of our work is helping build capacity for technical support. We help local teams identify and train local biomedical engineers. That will be the go-to person that the neurosurgeon could reach out to in case of a problem with NUNAV or in case of technical questions related to the system. It's really, really important that each team has a biomedical engineer associated with the NUNAV system to help with technical aspects. NUNAV is a collaborative research platform. It's open source software that is constantly evolving, and we try to use feedback from clinical end users to provide materials for adding or improving missing features. NUNAV is built by a multidisciplinary team of clinicians, scientists, and engineers who all have a different set of expertise and skills. And we try to leverage this complementary set of skills to make NUNAV a better system. And I would like to end my presentation by acknowledging the support that we receive from our funders, who include the Jennifer Oppenheimer Cancer Research Initiative, the McMahon family, Sally Seaver, as well as anonymous donors. We're immensely grateful to the donors of NUNAV who make this project of bringing open source neuronavigation in low and middle resources countries possible. And now I would like to leave the floor to Colton for the live demo of NUNAV. Thank you very much.